All right, everybody, welcome to the video here for lesson number 2. In lesson 1, we talked about a new fun equation of a line, and in lesson number 2, we're going to talk about the differences between parallel and perpendicular lines. So the opening exercise is having us remember or try to remember how to graph a line. So I've given you 3 different lines that I'm asking you to graph. You could either use your knowledge of the equation of a line to graph by determining what the y-intercept is and the slope and going through that, or you could go through and plug them into your calculator and look in your table of values like you would have done back in Algebra 1 last year. So go ahead, pause the video and try and graph the 3 equations of a line here. All right, so hopefully you graph them the same way that I did here. So notice I labeled each one as M, H, and K like they asked us to. It looks that M and H look to be parallel to each other, and it looks like M and H look to be perpendicular. Same thing with K and H. So they look like they're intersecting there at 90-degree angles. So let's take a look at the questions on the bottom. So it says, what do you notice about the slopes of M and H? So looking at M and H, the slope of M is 2. The slope of H is -1/2. So what we would have called these back in Algebra 1 would have been negative reciprocals. And it says, do they intersect? The answer to that question is yes. Then it says, what do you notice about the slopes of M and K? Well, K has a slope of 2. So M has a slope of 2 and K has a slope of 2, so they're the same slope. All right, so these are the same slope. And then it says, do they intersect? And the answer is no. So it says, make a general statement about how the slopes affect the lines in this graph. All right, so we could say parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. I'm abbreviating because all of this is going to be explained further on the next page. So on the next page, it tells us kind of a summation of what we just talked about here in the opening exercise. It says the slope of a line can help us determine if the 2 lines are parallel or perpendicular. If the lines are parallel, they have equal slopes, meaning the slope is going to be exactly the same value, just like lines M and K here in the opening exercise. Then it says perpendicular lines will always have negative reciprocal slopes. So negative reciprocal slopes are like 2 and -1/2. They're reciprocal, meaning we're flipping the fraction and changing its sign. So before we can kind of go and dig deep into what we're actually trying to accomplish today, we first have to practice what a negative reciprocal is. So here's 4 different values, and I'm asking you to find the negative reciprocal for each. So part A has a fraction of 3/2. If I find the negative reciprocal of that, it becomes -3/2. No, that's wrong. It would be -2/3. Right? Notice I'm flipping the fraction and I'm changing its sign, so positive becomes a negative. For part B, if I flip the fraction and change its sign, the negative reciprocal there becomes +5/4. Part C is an interesting one. This is actually a fraction. It's -1/1. If I flip that, it's still going to be 1/1. And then if I change the sign, it's going to be a +1/1. So we'll just say 1. 4 is also a fraction. It's 4/1. If you flip that and change its sign, it becomes -1/4. So let's take a look at an example here. Number 2 says, determine if these 2 equations of a line are parallel, perpendicular, or neither. This is like one of those questions that's on the Regents exam every single year. It's either a multiple choice question where they say which of the following are parallel or which of the following are perpendicular, or it's a show a work question like example 2 is, where I'm asking you, are these parallel, perpendicular, or neither, and to justify your answer. So all you have to do is put your equations into the form of y = mx plus b. This form, not the form we learned in lesson 1, because this form clearly identifies what the slope is, and it's easiest to do when the equations are already provided for us. So if we take a look here for this first one, so we have 3y is equal to 2x plus 9. If I divide everything here by 3, I get y is equal to 2/3 of x plus 3. So the slope of this line is 2/3. If I do the same thing for the second equation, so I have 2y is equal to 15 minus 3x, divide everything by 2, and we get y is equal to 15/2, or whatever that equivalent decimal is, 7.5, minus 3/2 x. Notice, I don't care what the y-intercept is. I'm only interested in the slope. The slope tells me everything. The slope is always the number multiplied to x, so even though this is not exactly in the right form, I can tell that the slope here is -3/2. So because these are not the same value, I know it's not parallel, but notice they are negative reciprocals. So I can say perpendicular, upside down uppercase T is the symbol for perpendicular, because the slopes are negative reciprocals. All right, so let's use then now what we learned yesterday and apply it to what we're learning here today. So in lesson 1, we learned this new fun equation of a line, which was y minus y1 equals m times x minus x1. And we used that whenever we had a slope and we had a random point on the line. Well, that's what this question is telling us. So it's giving us an equation of a line that wants to pass through the point 5, -12, there's your point, but it wants to be perpendicular to this line. So if I want to be perpendicular, I first need to determine the slope of this line. So to determine the slope of this line, I'm going to put it into y equals mx plus b. So I start by dividing everything here by 6, and we get y is equal to 5/6x plus 12. Again, the plus 12 is irrelevant. All I care about is the slope. Now that's the slope of the line, but I want to create an equation of line that's perpendicular to this line. So to be perpendicular to this line, I need to figure out, well, what's the perpendicular slope? So if the slope of the line is 5/6, the perpendicular slope would be -6/5. So then if we go through and we want to create a line here, right? So we want to create an equation of a line that has this slope and passes through this point. These two things are connected. So to create an equation of a line that goes through this point and has this slope, I would say y minus -12 is equal to -6/5 times x minus 5. Double negative becomes a plus, so we'll change that to plus 12. And I'm even going to distribute here just to make my life easy, right? All in one step. I then can subtract the 12 over to the other side, and now I have a nice equation of a line, right? That is in y equals mx plus b form. That's a perfectly acceptable answer. If it doesn't specify, like this question doesn't specify, this is actually an acceptable answer too. These are both equations of a line. The difference is the one that I highlighted in red is in what we call point slope form. The one I highlighted there in green, that's what we call slope intercept form. So it all depends on how they ask the question. If they leave it wide open, well, then guess what? Either one is acceptable. So right below this, where if we were doing this in class, I would say with your partner, discuss how you would have done this question differently if the question said parallel instead of perpendicular. So go ahead, pause the video for a second, think about what would change here, and let's see if you come up with the same answer as me. All right, so welcome back. Hopefully you paused the video and actually thought about this. So if this was perpendicular, instead of using the negative reciprocal slope, right, we would use the parallel slope, right? That's the symbol for parallel, which is the same thing, so a 5 over 6. So the equation would look very different. The point would still be the same, but we'd have a different slope, so it would change a little bit. So guess what we're doing in exercise 4? In exercise 4, we're going to use the same point and the same equation of a line, but this time I'm changing the word to parallel. By changing the word to parallel, I'm just going to change one step of this problem. So the first step is still the same. If I divide everything by 6, I should get the same equation. So we have 5 over 6x plus 12. The slope of this line is 5 over 6, so the parallel slope of this line is also 5 over 6. So if we go through and write our equation of a line, I would say y minus negative 12 is equal to 5 over 6 times x minus 5. Again, I'm using this point and this parallel slope. These are the two things that are attached. Clean up the double negative and do my distributing. So when I distribute here, I'm going to get 5 over 6x minus, now if I type that into my calculator, 5 over 6 times negative 5, it's going to give me a decimal. Now, it's not a nice decimal. Because it's not a nice decimal, it's going to be like 4.1 ... forever. We want to leave the fraction. Don't use a decimal that you have to round. So just hit math, enter, enter on your calculator, and a nice fraction will pop up for you. You then can subtract 12 to the other side, again, doing all of this in your calculator, and we would get 5 over 6x minus, if you do 25 over 6 minus 12, you're going to get another nasty decimal. Just hit math, enter, enter, and you will get 47 over 6. There's your equation of a line. Number 5 is my attempt of combining things from a previous chapter to what we're currently doing. So the first thing it asks us to do is to graph 4 points that create a square. So we have 1, 2, there's 1 point. We have 5, 2, there's a second point. We have 5, negative 2, there's a third point, and 1, negative 2, giving us the square BASE. Use a nice straight edge here to create your lines, and we have a nice little square. It then tells us the equation of a line that cuts through diagonal SB is negative x plus 3. So negative x plus 3 is going to be this line. How do I know it's this line? I'm using my straight edge. I'm connecting S and B, and I'm drawing a straight line through. This line should intersect the y-axis at positive 3, which it does, and it should have a negative 1 slope. Now, one of the things that we learned in the parallelogram chapter was that a square has diagonals that are perpendicular to each other. So that means the equation of the line that would cut through AE would also be perpendicular to this line. So this line has the equation y equals negative x plus 3. The slope of this line is negative 1. The perpendicular slope to that is positive 1. Now, I want to create a line that passes through point A and point E, so I just have to pick one. So if I pick point A and this slope, I'm just creating a line that passes through the point 5, 2 and has a slope of 1. So I would say y minus 2 equals 1 times x minus 5. Now, if you do some distributing there, 1 times anything is itself, and then add 2, we notice we get a similar looking equation, but different. We have x minus 3. Meaning, if I was to draw a straight line from A to E using my straight edge, it should intersect the y-axis at negative 3. That would prove that this was the correct equation. So go ahead, use your straight edge and draw it in there. You see that if I drew a good line there, I didn't use my straight edge appropriately. We see it does pass through that correct point. Also, it looks to be perpendicular to this original line that created SB. And we notice the slopes are perpendicular. So there's your equation that they're looking for. Hopefully this video helped and you are starting to understand what parallel versus perpendicular slopes are. Before you go on to the homework, pause the video. This way you could try the questions first, see how you're doing on your own. And as you're doing the homework, notice it is on page 9 and 10. It goes on to a second page. It's only 4 questions, but it does go on to a second page. So pause the video and come back to us. This way we could see if you did all these questions right or wrong. All right, so welcome back. Hopefully you paused the video and you tried all these on your own. Now that you've done them, let's see how you did. So for the first question, it asks us to determine if these two equations are parallel, perpendicular, or neither. For that, we need to know slope. Luckily, this first one's in a nice format for us. It's in this new form that we learned, y minus y1 equals m times x minus x1. So the m in this case is 3. So we already know the slope of this line without really having to do much work. The second one is not in a nice format, so we got to get rid of the -4. So we divide everything here by -4. We get y equals -5 plus 3x. Again, slope is always the number multiplied to x, so in this case the slope is also 3. Since both of these equations have the same exact slope, that tells us that these lines are parallel, and we can say because the slopes are equal. All right, we have the same exact slope here. Number 2 is very similar to a question we did in class. So it tells us the equation of a line, and we want to find a line that passes through the point -1, -6 that's parallel to this line. So to be parallel, we need to know the slope of that line. The slope of this line is 1/2. The parallel slope is also 1/2. Remember, the slopes are the same. So we want to create a line that passes through this point and has a slope of 1/2. So I'd say y minus -6 equals 1/2 times x minus -1. Lots of double negatives here. Anytime I see a double negative, remember it changes to a plus. So we have this going for us. Do some distributing. So I have y plus 6 equals 1/2 x plus 1/2. If I then subtract 6, we get y equals 1/2 x minus, if you do this in your calculator, you're going to get -5.5. That's fine. I personally like fractions better, so I'm going to put 11/2. If you get -5.5 and you wrote that here, that's totally cool with me. Just leave it. It's okay. Don't erase it. Let's take a look at 3. Number 3 asks us to write an equation of a line that passes through the point 4, 12 and is perpendicular to the line 4x plus 2y equals 10. Well, to do that, I first need to find the slope of this original line. So I have 4x plus 2y equals 10. If I subtract 4x to both sides, I get 2y equals -4x plus 10. I like putting the x first. If you didn't, it's not wrong. Divide everything here by 2, and we get y equals -2x plus 5, which tells us the slope is -2. But I want a perpendicular line. So I want to know the perpendicular slope, which would be +1/2. I'm taking the negative reciprocal here. So I want to pass through this point, +4, 12, and have a slope of +1/2. So I'd say y minus 12 equals 1/2 of x minus 4. Do some distributing. I get y minus 12 equals 1/2 x minus 2. Add 12 to both sides, and we get our nice equation 1/2 x plus 10. Again, this is a perfectly acceptable equation of a line. We're just more familiar with this one, which is why we keep going and doing those extra steps. Either one is an acceptable answer. All right, on the next page, it gives us a rhombus. right? What do we know about a rhombus? As soon as we hear the word rhombus, we know that the sides are congruent and the diagonals are perpendicular, right? We know a lot about this shape. So when we start graphing it, just start to think about that. So I have the point 1, 2, I have the point 8, 1, the point 3, negative 4, and the point negative 4, negative 3. And we're calling this T, I, M, E. Whenever you're graphing something, please, please, please use a straight edge to connect your points as best you can. It's kind of hard to do this on my computer, but I will attempt every time for you. If you don't have a ruler at home, it's okay. Just use the edge of a notebook, something straight. I've even had kids use the edge of their calculator, cover, whatever works for you, as long as you're making nice straight lines. So it then tells us, just like the question from class, that the equation that connects t and m is negative 3x plus 5. So if I was to use my straight edge to connect t to m, it should pass through the y-intercept of positive 5, and it should have a slope of negative 3 over 1, which it does. There's your line. Passes through at 5, so we're good. Now, one of the things that's true about a rhombus is that the diagonals are perpendicular to each other. So the equation of the line that's going to pass through EI is going to be perpendicular to this equation. So the slope of this equation is negative 3. The perpendicular slope is positive 1/3. Then I just have to pick one of the 2 points, I or E. It doesn't matter. I'm going to pick I because they're nice positive numbers. So if I take that equation, or if I start to make this equation, I'm going to say y minus 1 equals the slope of 1/3 of x minus 8. If I distribute 1/3, y minus 1 equals 1/3 of x minus, if you type 1/3 times negative 8 into your calculator, it's going to be a decimal. That decimal has to be changed to a fraction because it's not a nice decimal. So if you change it to a fraction, it's going to be 8/3. If you then add 1 to both sides, the ones cancel, and you're left with y equals 1/3 of x minus, again, if you do this in your calculator, you're going to get a decimal. Change the decimal to a fraction. We want the fraction, right? So if we change that fraction, that decimal to a fraction, it becomes 5/3. There's the equation that connects I to E. Meaning, if I was to draw that line in, I'll do it in a different color here, right? If I was to draw that line in, it should have a slope of up 1 to the right 3, and it should pass through the y-axis at negative 5/3, which is about 1.7, if you were to estimate it. So it looks to be a good slope, and if you look, the y-intercept is somewhere between negative 1 and negative 2, so about negative 1.7, where we thought it would be. Hopefully this video helped. Make sure that you are clicking that you completed this on Google Classroom, and we are good to go. All right, hopefully I see you soon.